The ear is actually a complex network of three different portions, two of which are going to be responsible for transferring the sound, and one of which is going to be responsible for detecting that sound, as well as movement within our body. Now, describe the ear is just the external or the outer ear. And this is the portion that is going to receive the sound waves and then push it or transfer it towards the opening on the sides of our head known as the external acoustic meatus. So this is a small opening where you would hopefully clean your ears periodically with a Q-tip. So the sound is going to transfer from our external environment through this opening of the external acoustic meatus, which is part of our external ear. Now, the other portions of our ear are going to be located within bony or skeletal elements within the temporal bone of our head. So in this illustration, we can see the three parts. The external or outer ear, which is made up of this elastic cartilage and the external acoustic meatus. Then we can see the middle ear, which is going to be a hollow chamber within this bone. And lastly, the internal or inner ear, which is actually within the bone itself and has multiple elements. So let's now take a closer look at the structures within the middle ear. The boundary between the external ear and the middle ear cavity is our eardrum, which is actually called the tympanic membrane. So, as sound travels from the outer ear down this external acoustic meatus, it's going to cause vibrations of the tympanic membrane. Now, in order to detect that sound, we need to travel through the middle ear towards the inner ear. And this is going to be the role of three small bones, otherwise known as the ossicles of the ear. The first of which, the malleus, is named because of its hammer-like appearance. It will be attached directly to the tympanic membrane. So, as the membrane vibrates, we're going to get small movements of the malleus. The next bone that the malleus articulates with is the incus, which is an anvil type of shape. So the malleus moves the incus, which is now going to transfer movement to the smallest of the three bones, the stapes. And we can see that the small area of the stapes is going to now be producing all of the movement that was transferred from the tympanic membrane. So we're now going to leave the middle ear and enter the portion of our ear known as the internal or inner ear. Here we're going to have two different elements. The vestibule, which has the semicircular canals. These are circular tubes that are going to be half loops oriented in kind of an X, Y, and Z orientation. So as you rotate or spin in any different direction, the semicircular canals are going to be responsible for detecting that movement. So this is really important for balance. Now the cochlea, the snail-shaped portion of our inner ear, is the portion that's going to be responsible for detecting the sound. So we're going to have two elements to our inner ear, a sound portion and a movement or balance portion. How we're going to get the nerves to both of these elements is through an opening on the inside of our skull known as the internal acoustic meatus. This is where cranial nerves 7 and 8 leave the skull to start their path towards their target structures. Now 7 is going to continue through this area to get to structures in our face, but cranial nerve 8, the vestibulocochlear nerve, is going to travel in this bone towards the vestibule and the cochlea. So cranial nerve 8, vestibulocochlear nerve, is responsible for our detection of balance and